Hi everyone, in this video I'm going to solve A-Levels Pure Mathematics Paper 2 in a session May-June 2022 Paper 2-2. So let's start with the first question. Question number 1, given that y equals to ln of x over x square, find the exact value of dy over dx when x is equals to e, right? So we can use a quotient rule over here. Let me find dy over dx. The denominator function square. The denominator function derivative of a numerator function is 1 over x minus the numerator function is ln of x, derivative of denominator function is 2x. So here dy over dx, this would be equals to x square over x. This would be just x minus 2x ln x over x power 4. Right, now let me find the derivative at x is equals to e minus 2e ln of e over e power 4. We know that ln of e is 1, right? So we have e minus 2e over e power 4, right? Or further simplification, minus 1e over e power 4. So e power 3 is left here. So the simplified answer is minus 1 over e cube. Question number 2. Part A, sketch on the same diagram the graph of this absolute function and the linear function, right? Let me start with the absolute function. We have a function y equals to absolute of 2x minus 9. Let me solve this without absolute. The x-intercept when y equals to 0. So 2x minus 9 equals to 0 and x would be equals to 9 by 2. And 9 by 2 is 4.5. Let's do the y-intercept. When x is equals to 0. So y would be equals to 2 times of 0 minus 9 with absolute. So y would be equals to 9. Right. X-intercept is 4.5. Y-intercept is 9. Okay. And let me fix one more point to get the y value, right? So 4.5 y is 9. So if I can take at x is equals to 6, what is y? Absolute of 2 times 6 minus 9. 3. Y value is 3. Right. Now let's do the second function, the linear function y equals to 5x minus 3. Y equals to 5x minus 3 and solve for the x and the y-intercept. X-intercept y is equals to 0. So 5x minus 3 would be equals to 0. So x would be 3 by 5. And 3 by 5 is 0.6. Right. And the y-intercept, when x equals to 0, we have y equals to 5 times 0 minus 3. Y value is negative 3. Right. Now let me sketch the graph on the same diagram. Okay. So let me select the scale by 1, 9, 6. Okay. We have 1, 2, 3, 4, 5, 6, minus 1, minus 2, minus 3, minus 4. And over here, 1, 2, 3, 4, 5, 6, 7, and minus 1, minus 2, minus 3, minus 4, minus 5, and minus 6. Okay, so this is 1, 2, 3, 4, 5, 6, 7. If I can do the scale of 2, 4, 6, 8 with a negative sign, and you have 2, 4, 6, 8, 10, 12. Okay, the first function, the absolute value function, the x-intercept is 4.5 over here, and the y-intercept is 9 over here, right? Okay, let me connect these 2 points, the x and the y-intercept. Okay, right. And the other thing, when x is 6, the y is 3 we got. When x equals to 6, the y value is 3. So here x is 6, y is 2, and the middle is, this is 3. Middle of 4 and 5. Let me connect this with the vertex. Right. This is a graph for the absolute value function, and for the linear function, x-intercept is 0.6. Okay, 0.6 would be over here, and y-intercept is -3. Right. Let me connect the x and the y-intercept. So this is a straight line for the linear function. So this is a graph, sketch of the two graphs on the same diagram, right? Moving to part B, solve the equation. We have to find the value for the solutions. Okay, if I open this, we have plus minus 2x minus 9. This is equals to 5x minus 3. Let me get rid of this plus minus. Let's do the scaling on both sides. So 2x minus 9 whole square, 5x minus 3 whole square. So 2 square is 4x square, 3 square would be 9 square, 9 times 9 is 81, and 2ab. So 2 times 2 times 3 would is 12 minus, sorry, it's 9. 2 times 2 times 9 minus 36. X. 25x square plus 9, 5 times 3 times 2, which is 30, minus 30. X. So from here, shifting all the terms to the right side, 25x square minus 4x square minus 30x, and shifting this plus 36x plus 9 and minus 81 would be equals to 0. So from 25 take away 4 is 21x square. From 36 take away 30 is minus positive 6x, and 9 minus 81 is minus 72. This would be equals to 0, right? So we can divide it by 3 times table. Yes, 3 times 7 is 21, 3 times 2 is 6, and 7x square plus 2x minus 24, this is equals to 0. Let me factorize this. 7 times minus 24 is 168, and 12 times minus 14 is minus 168, and 14 minus 12 would be 2. 7x square plus 14x minus 2x, 12x minus 24 would be equals to 0. 7x is common, which is x plus 2, minus 12 is common, x plus 2. This is equals to 0. 7x minus 12 is the factor, and x plus 2 is the factor. So from here we can say x is equals to -2 is the solution, and x is equals to 12 over 7 is the solution. What is 12 divided 7? 1.714. Okay, but from the sketch we can see only the solution is when x is positive, right? So this is the only solution, is x is equals to 12 over 7. Now question number 3. A curve has an equation this. Find the exact gradient of the curve at a point 0 and pi by 6. Okay, so we have to differentiate this using the product rule. The first function 2x is e power 2x is as it is. The derivative d by dx of cos 2y plus d by dx of sin y equals to d by dx of 1. Oh, I missed the one step for the product rule over here. Plus cos 2y is as it is, and the derivative is e power 2x into 2. Right. Sorry. E power 2x. The derivative of cos is sine. We have sine 2y into 2 dy over dx. Cos derivative is negative sine, sorry. And plus 2 e power 2x cos 2y, right? And plus sine derivative is cos y and dy over dx equals to 0. The constant derivative, one derivative is just 0, right? Okay, let me simplify this. Minus 2 e power 2x sine 2y dy over dx plus 2 e power 2x cos 2y plus cos y dy over dx. This is equals to 0, right? Now let me take dy by dx common, and we have these two terms, right? We have cos y minus 2 e power 2x sine 2y. This would be equals to minus 2 e power 2x cos 2y. Okay, now dy over dx, this would be equals to minus 2 e power 2x cos 2y divides cos y minus 2 e power x 2x sine 2y, right? Now we need to find the exact gradient of the curve at a point 0 and pi by 6, right? Let me substitute the point 0 and pi by 6. So we can say dy over dx at x is equals to 0 and y equals to pi by 6. So we have minus 2 e power 0 cos 2 times pi by 6 over cos pi by 6 minus 2 e power 0 sine 2 times pi by 6. Okay, let me calculate this. So e power 0 is just 1. Cos 2 pi by 6, cos 2 pi divided 6 is 1 by 2, and times minus 2, which is minus 1 in the numerator, over cos pi by 6 square root of 3 by 2, and sine 2 pi by 6, sorry, sine 2 pi by 6, sine 2 pi by 6 times minus 2 minus square root of 3, right? Now let me simplify. Minus square root of 3, we need to add square root of 3 divided by 2 is this term. So this is minus 1 over minus square root of 3 by 2. So negative sign is cancelled with negative, so do the reciprocal. 2 over square root of 3 is the exact answer for the gradient. Now question number 4, part A. Use the trapezium rule with 3 intervals n is equals to 3 to show that the value of 1 to 4 ln x dx is approximately ln of 12. So the formula for the trapezium rule is a equals to half times h, right? The function value at 1, because starting from 1, plus 2 times the function value at 2, plus 2 times function value at 3, plus function value at 4, right? And what is h? H is b minus a over n. So a and b are the upper and the lower limits. So from here a is 1 and b is 4. 4 minus 1 over n is 3. So 3 over 3, which is equals to 1 in our case, right? So the trapezium rule is 1 by 2. H value is 1. So function ln of 1 plus 2 ln 2 plus 2 ln 3 plus ln 4. Right, let me simplify this. This would be 1 by 2. Ln of 1 is just 0. So ln of 2 square, ln of 3 square, ln of 4, right? 1 by 2. Ln of 4, ln of 9, ln of 4. So we need to do the product here. 1 by 2 ln of 4 times 9 times 4. 4 times 9 times 4, which is 144. 1 by 2 ln of 144, which is ln of 144 power is 1 by 2, and the square root of 144 is 12. Right, this is ln of 12. It is proved that it is equals to ln of 12. Now for part B, use the graph of y equals to ln x to show that ln 12 is an underestimate of the true value of 1 by 4 ln x dx. Okay, let me sketch the graph for this between 1 to 4. Okay, so let me do the scaling first. We have 1, 2, 3, 4, and over here 1, 2, 3, 4. We have to do till 4. Yes. Okay, so first we have to find the value for ln of 1, which is 0. What is ln 2? Ln of 2 is 0.69, or we can say 0.7. Okay, this is the value of 2. This is 1, and 0.7 is over here. We can say this point, right? Ln 3 is 1.9 or 1.1. Ln of 3 is 1.1. This is 1 and 1.1. Ln 4 is 1.4. This is the point 1. We have 1 here, and we can say 1.4. Right. Now let me connect all the points to get the sketch for ln of x. And the downward as well. Okay, so this is a sketch for ln of x. So if we look at the trapezium, we are looking for 3 intervals, 1, 2, and 3. We have to find the area of each trapezium. This one for this trapezium and for this trapezium, right? Now the question is why this is underestimate, right? So this is underestimate. As you can see, we are doing 3 intervals. This is 1, this is 1, 2, 3, and 4. The intervals 1, 2, and 3, we have to find the area of these 3 trapeziums. We are not filling these gaps. Let me highlight these gaps with a green. We are not finding the areas of these gaps. That is why it is underestimate. The gaps between the curve and the trapezium. The curve and the trapezium, we are not working on this area. That is why it is underestimating, because we are not counting the small pieces, right? So we can say that we are not counting the gaps between the curve and each trapezium. That is why it is underestimated. Right. Question number 5, the polynomial p of x is defined by, we have a polynomial where a is a constant. It is given that x minus 4 is a factor of the polynomial. Part A, find the value of a and hence factorize p of x. So if x minus 4 is a factor, so it means p of 4 should be equals to 0, right? Let me solve for p of 4. 2 times 4 cube plus a 4 square minus 3 times of 4 minus 4, this would be equals to 0. From here we can easily get the value of a, right? Okay, so 4 cube is 64 times by 2, which is 128. 4 square is 16a minus 12 minus 4, this is equals to 0. 128 minus 12 minus 4 is 112. Divide times by minus 1 and divided by 16. So the a value is negative of 7. From here we got the a, which is negative 7. Right. Now we have to factorize the polynomial, the cubic polynomial. Let me rewrite the polynomial by substituting the a value. P of x would be 2x cube minus 7x square minus 3x minus 4. Okay, let me use the synthetic division method here. Okay, right. Let me write down the coefficients of x cube, x square, x coefficient and the constant term, right? And we have given the information that x minus 4 is the factor of this polynomial. So we have 4 here, bring the 2 down. 4 times 2 is 8. This is 1, 4 times 1 is 4, this is 1, 4 times 1 is 4, and this add up to 0. Now these are the coefficients for the quadratic. So we can say p of x, we can write this down as x minus 4, 2x square minus plus x plus 1, right? So now factorize this quadratic equation. So before factorization, let me check the discriminant, whether it has the real roots. So which is b square minus 4ac. So b square is 1 square minus 4 times the a value and the c value. So this is 1 minus 8, which is negative 7. So this is less than 0. So it has no real solution. So this is the only factorized form for the polynomial. Now for part B, show that the equation p of e power 3y equals to 0 has only one real root and find its exact value. We have the polynomial in factored form from part A, which is x minus 4 and 2x square plus x plus 1. From here we know that there is no real solution, real root. So no real root. So if I can say p of e power 3y equals to 0, so it means we have e power 3y minus 4 into 2 times e power 3 times 2 6y plus e power 3y plus 1. This would be equals to 0, right? So from here we can say e power 3y minus 4 would be equals to 0. E power 2e power 6y plus e power 3y plus 1 equals to 0 has no real solution. We already checked from the discriminant from part A, right? So let me solve this. So e power 3y would be equals to 4. What is 3y? Which is ln 4. And the y value is 1 by 3 ln 4. This is only one real root. Question number 6. The diagram shows the curve y equals to 3 e power 2x minus 1. The shaded region is bounded by the curve and the lines x equals to a, x equals to a plus 1, and y equals to 0, where a is a constant. It is given that the area of the shaded region is 120 square units. Part A show that a value is this. So using the information that area, the shaded area we have given, so this is a shaded area, so we can say that the shaded area is integration of the curve from a to a plus 1. So the curve is 3 e power 2x minus 1 dx, right? Let me do the integration and applying the limits. So we have 3 e power 2x plus minus 1, and the derivative of 2x minus 1 is just 2. This would be from a to a plus 1, and the area is 120. Okay, so e power 2x minus 1, we can say 120 times 2 by 3 from a to a plus 1, sorry. Now let me substitute the limits. The upper limit is e power 2 times of a plus 1 minus 1, minus the lower limit is e power 2a minus 1. This is 120 times 2 over 3. 80. Okay, so e power 2a plus 2 minus 1 minus e power 2a minus 1, this is equals to 80, right? So e power 2a plus 1, e power 2a minus 1 equals to 80, right? So how can we rearrange this? As you can see in ln, we have 80 and e power 2a minus 1. So shifting this term over on the other side, e power 2a plus 1 gives me 80 plus e power 2a minus 1, right? Taking ln on both sides, so 2a plus 1 is ln of e power 2a minus 1 plus 80. ln of 80 plus e power 2a minus 1, right? Now let me solve for a. So to get the value for a, 2a would be ln of 80 plus e power 2a minus 1 minus 1 here, and a value is 1 by 2 ln of 80 plus e power 2a minus 1 minus 1 by 2. We got exactly the same a value, right? Now for part B, use an iterative formula based on the equation in part A to find the value of a correct to 3 significant figures, giving your result of each iteration to 5 significant figures. So the iterative formula is an plus 1. This is equals to 1 by 2 ln of 80 plus e power 2an minus 1 minus 1 by 2. You have to solve for a, right? Okay, now we have to select the initial guess, the initial value for a. So as you can see, the a value is not 0. So we are not taking it 0. Maybe it is 1 or 2, 1, 2 or 3. So let's see what is the initial guess. So if the change occur, then we have a root. Okay, so first we need to do the initial guess. Okay, let's say the a value is between 0 and 1. If I can take 0, an is equals to 0, and 1, an equals to 1, between 0 and 1. Okay, so if I can do substituting the value over here, so log 80 plus e power 1 negative 1, it's 0. Okay, divided by 2, subtract 1 by 2, which is 0 0.45, 0 0.45, right? And at 1, So ln of 80 plus e power at 1, 2 times 1 minus 1 e power 1, and divided by 2 minus 1 by 2. This is 1.70, right? So we have, we can say 0 is less than 0.45, and 1 is also less than 1.70. So there is no root between 0 and 1. Okay, now the next guess is between 1 and 2. So if an is 1 and an is 2, so an is 1, the answer is 1.70. Let me check at 2. Okay, we have ln of 80 and plus e power, we have 2 times 2 is 4, and 4 minus 1 is 3, divided by 2, subtract 1 by 2. So 1.80, this is 1.80. So 2 is greater than, sorry, I did mistake here. 0 is less than 0.45 and 1 is less than 1.74. It means there is no inequality change occur, so no root between 0 and 1. Now 1 is less than 1.70, but 2 is greater than 1.80. Now inequality change occur. So what does it mean? It means that root lies between 1 and 2. So we got our initial guess, right? Let suppose that a naught, the initial guess, is between 1 and 2. We can take 1.5, right? And let's find the iteration. We can do an and an plus 1, right? Up to 5 significant figures. Okay, let me rewrite the equation. An plus 1 should be equals to 1 by 2 ln of 80 e power plus, this is plus 2an minus 1 minus 1 by 2. So the initial guess, we start with 1.5. A naught is 1.5. Okay, so ln of 80 plus e power 1.5, 2 times 1.5 and we have subtract 1 bracket divided by 2, this is bracket, and minus bracket 1 by 2. 1.735 up to 5 significant figures. 1.7352. Okay, let me check at the answer. 1.7352. This is at 1.7599. Okay. 1.7599. We have 1.763. Okay, and the next is 1.7632 is 1.7636. The next is 1.7636, 1.7637. Okay, so this is at 1.7352, 1.7599. The value is this, 1.7632, 1.7636, up to so on. We have to find the root up to 3 significant figures, right? So we have 1.7 is common. So we have 666. So 1.76 is the answer. The root up to 3 significant figures. This is the value which lies between 1 and 2. Question number 7. The diagram shows the curves y equals to this and y equals to this for axis between 0 to pi. The shaded region is bounded between two curves and a line x equals to 0. Find the exact area of the shaded region. Okay, so the top curve is basically y equals to square root of 2 pi minus 2x, and this bottom curve is y equals to sine square x. Right, so the area between the two curves, the top minus the bottom, right? So to find the shaded area, we have to integrate between 0 to pi square root of 2 pi minus 2x, subtract sine square x dx. Right. Okay, let me do the integration. So we have to do integrate 0 to pi square root of 2 pi minus 2x minus sine square x. We have to use a formula which is 1 minus cos 2x over 2 dx. Okay, so the integration for the first function is we need to use a power rule, which is square 2 pi minus 2x. The power is 1 by 2 plus 1 over 1 by 2 plus 1, multiply its 1 over the derivative, which is minus 2. Okay, then minus 1 by 2, this is 1 by 2x, and minus minus plus 1 by 2, and cos 2x integration is sine 2x over 2. From 0 to pi. Right, so here we have 2 pi minus 2x, its power is 3 by 2, denominator is also 3 by 2, so we can do 2 by 3 times minus 1 by 2 minus x by 2 plus 1 by 2 sine 2x over 2 from 0 to pi. Right, 2 is cancelled with this 2, so minus 1 over 3, 2 pi minus 2x, power is 3 by 2 minus x by 2 plus sine 2x over 4 from 0 to pi. Let me substitute the upper and the lower limits to get the shaded area. So minus 1 by 3, 2 pi minus 2 pi, power 3 by 2. I am substituting the upper limits first. Minus pi by 2 plus sine 2 pi over 4. Subtract the lower limit. Minus 1 by 3, 2 pi power 3 by 2. This is 0, minus 0 plus sine 0 over 4. Okay. This is minus plus 2 pi minus 2 pi is cancelled. This term would be 0. So from here we have just minus pi by 2. It is sine 2 pi. This is 0. It's radian sine 2 pi is equals to 0. Right. And sine 0 is also 0. Right. This term is 0. This is 0. This is 0. Minus and minus we have plus 1 by 3. 2 pi power is 3 by 2. And these two terms are also, this is 0 and sine 0 is also 0. So this is the exact shaded area between the two curves. Now question number 8, part A. Express this expression in the form of r sine theta plus alpha, where r is greater than 0 and alpha is between 0 to 90 degree. Give the value of alpha correct to 2 decimal place. Okay, so we have 3 sine 2 theta would be 2 sine theta cos theta. Secant theta is 1 over cos theta plus 10, and cos theta minus 30 degree is cos theta. Cos 30 plus sin theta and sin 30. So this would be equals to 6. Cos is cancelled with cos. Sin theta plus 10. We have cos theta. And what is cos 30 degree? This is in degrees. Cos 30 is square root of 3 over 2. Plus sin theta. Sin 30 is 1 by 2. Okay, 6 sin theta plus 5 square root of 3 cos theta plus 5 sin theta. Further simplification, we have 6 plus 5 would be 11 sin theta plus 5 square root of 3 cos theta. This is a simplified form of this expression. Now we have to convert it into r sin theta plus alpha, right? So this would be equals to r sin theta plus alpha. So we can say 11 sin theta plus 5 square root of 3 cos theta. This would be equals to r sin theta cos alpha plus cos theta sin alpha. Right. Now let me compare the coefficients. Compare coefficients of, let me do sin theta first. If I compare the coefficients of sin theta, we have 11 over here, and sin theta is r cos alpha, right? Next step, comparing the coefficient of cos theta. So cos theta is 5 square root of 3 here, and we have r sin alpha, right? First we have to solve for r and then for alpha, right? Okay, to get the value of r, let me do squaring on both sides, square and adding. So r square cos square alpha plus r square sin square alpha. This is 11 square plus 5 square root of 3 square. So we can take r square common. Cos square alpha plus sin square alpha. This is 1. 11 is 121. 5 square is 25. Square root of 3 square is just 3. So 25 times 3, which is 75. Plus 121. 169. Okay, so r square is 169. To get the value of r, we have to do the square root of 196, sorry, which is 14, and this is plus minus 14, but in the question we have a restriction that r should be greater than 1, so it should be positive of 14, right? Now the next is we have to solve the value for theta. So if I can do sine over cos, dividing the second over first, so r sine alpha over r cos alpha. This is 5 square root of 3 over 11. R is cancelled with r. Sin alpha over cos alpha would be tan alpha. This is 5 square root of 3 over 11. And what is alpha? Which is tangent inverse of 5 square root of 3 over 11. It should be in the first quadrant between 0 to 90 degree, right? So 5 square root of 3 divides 11. Tangent inverse of answer is 38.21. Up to 2 decimal place we have to find the answer. 12 is 38.21 degrees up to 2 decimal place, right? So we can say that the expression is in terms of r sine theta plus alpha, which is r is 14, sine theta plus 38.21 degrees. Right. Now for part B, hence solve the equation. As you can see, if I compare this with part A, we have 3 sine 2 theta, so 4 beta, so theta would be 2 beta. Secant theta, secant 2 beta plus 10 cos theta is 2 beta minus 30, this would be equals to 0. So basically theta is replaced with 2 beta. We have to solve this equation, and beta is between 0 to 90 degree, and we know that the answer for this equation is 14 sine theta, which is 2 beta, plus alpha, which is 38.21 degrees. We have to put it equals to 2. So sine 2 beta plus 38.21, which is equals to 2 over 14. Right, so 2 beta plus 38.21 degrees, this would be equals to sine inverse of 1 over 7. Now sine is positive in first and second quadrant, we have to find two values here. So 2 beta plus 37.21 degrees, this would be equals to sine inverse of 1 divided 7, which is 8.21 degrees. 8.21 degrees, and let me solve for beta over here. So 8.21 subtract 38.21 dividing by 2, which is negative 14.99 degrees, which does not belongs to 0 to 90 degree. Now sine is also positive in the second quadrant, so we have to do for the second quadrant as well. Right, now for second quadrant we have 2 beta plus 38.21 degrees, this would be equals to sine inverse of 1 over 7, and for second quadrant we do 180 minus theta, so 180 minus answer, this is 171.78 degrees. And we have to subtract 38.21 and divide it by 2, which is 66.78 or just 8 degrees. So here the value of beta is 66.8 degrees, which belongs to the domain 0 is less than beta is less than 90 degree. Right, so that was the last question of our paper. If you have any queries, please let me know in a comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.